Hey everybody, Isaac Cohen here. Very excited to be talking to you today about GitHub Actions, specifically third-party security actions. It's funny, I'm a field architect here at GitHub, and I've been in the CI market. I've been doing CI for about 10 years now. So very excited to be talking continuously about CI, CI/CD, GitHub Actions, but also its combination with security, and how do we start to integrate those third-party security actions as part of our CI/CD pipelines. Starting off with just giving you a brief introduction into GitHub Actions. Of course, as you know, GitHub Actions is the GitHub native CI/CD platform. What's interesting is that in the last year and a half that we've launched GitHub Actions, we now have over 5,500 actions in the GitHub marketplace. That's a tremendous amount of actions that essentially allow you to do whatever you like within GitHub Actions, but those extension points with partners or to do specific actions make your lives easier when creating these CI/CD pipelines. I should mention, by the way, like as you have questions, feel free to pop it in the chat. I'll be addressing them as we go. One of the things that we see, of course, is that there are a number of different actions from our partner ecosystem, whether they are developer tools and frameworks, or whether they are CI/CD and automation, or of course, cloud deployments and operations. I mean, as I mentioned beforehand, though, we're specifically going to focus on the third-party security actions today, and I'll actually walk you through how to integrate a number of different tools that are available. So we're going to focus on 3 tools today. We're going to focus on Anchore, which is concerned with container scanning, looking for vulnerabilities within containers. We'll look at Rubocop, which is looking for vulnerabilities within Ruby applications. And then finally, Codecy, which gives us a number of different options from code quality to also running a number of different tools in the background. It's important to note, though, that there are a lot more integrations that we're not going to cover in this session today, mainly one of them being CodeQL, which of course is the GitHub integrated security solution, and of course other partners that we just don't have time to review today. Well, I wanted to start off with the question, of course, like why should we be integrating security as part of our CI/CD pipelines? And to me, this focuses on that idea of shifting security as left as possible. So if you find any vulnerabilities, of course, in production or even as a result of a breach, it's exponentially more expensive to fix and to remediate than if you find them earlier in that life cycle, in the development part, or the or really before any QA occurs. So this is why we're trying to integrate all of these different tools as part of our CI/CD pipeline. But also, as we start to integrate this earlier on, developers are at least able to remediate those issues as quickly as possible. What's interesting is when I used to develop full-time, we always had this sort of game that we would play where we're not actually doing the security scanning until way later on, probably right before we go into production. Then we have to make this decision of whether to go into production knowing that we have these vulnerabilities, or whether to delay our production rollout. And so, of course, as we start to integrate security in as early as possible, those decisions become far and few between at that point. Okay, so let's get started. So a lot of the stuff I'm going to be showing you today, you can follow along, all on open source repos. We're going to start with Anchore and really integrating the Anchore engine. As I mentioned beforehand, Anchore engine is an open source project. So this provides centralized server. This pretty much allows you to scan your Docker containers, your containers, for any vulnerabilities. And if we think about Docker, there's a number of different, or if we think about containers, there are a number of different layers, whether it's the operating system or the application itself. We're going to want to start to analyze those containers, because they are software as well, to see if there are any vulnerabilities before we ever go into prod or anything like that. So moving over to my repo that I've created for this, of course, you can follow along, github.com/issc29. You'll notice that this is a demo instance. This is a demo repository that I created yesterday. It's a simple Node.js app. It's going to be installed as part of a Docker container. So we are going to create this actions pipeline that builds the Docker container, and then we will integrate Anchore as part of our container scanning solution. Before I continue, let's see if there are any questions. How easy is it to run GitHub Action workflow in a self-funded Azure instance? For example, to get access to more resources, cores, memory, etc. Thank you for that question, Keyhost. So you do have the ability to run a self-hosted runner. It's actually pretty easy to get started with that. Check out the documentation for GitHub Actions self-hosted runners. So if you check out this documentation, it will show you how to get started on Azure, to create your own runner on Azure, and then use that as what we would term as a self-hosted runner with GitHub Actions. It's really just a small file that you need to run, and that will then connect up to the GitHub orchestration as part of GitHub.com. And you know, obviously, like with Azure, AWS, GCP, whatever cloud hosting provider you're using, then you can control how much resources you have, cores, memory, et cetera, et cetera. Okay, so moving back to the actual Anchore demo, I'm going to click on GitHub Actions. And you'll see it gives me a number of different workflows out of the box, whether it's publishing a Docker container. I'm just going to create one myself. So we'll call this Docker CI. Okay, so the first thing that we see is on push, right? So every time we push or every time we open up a pull request, we will want to run this workflow. We have jobs, runs on. Okay, we're gonna want to run on Ubuntu latest. That's exactly what I want to do, especially because this is a Linux Docker container. I'm gonna run this as part of Ubuntu. It has Docker or the Docker daemon already installed, so it makes our lives very easy. And of course, the first thing that we'll do is we will check out the code. Okay, so now this is where we have to change a couple of things around. The first thing that we're going to want to do is just build our image. So we'll create a new step. Oops. And we will say, let's call this build a Docker image. So build the Docker image. And for this one, we're just going to run a command. It's going to be docker build dash file. So we're going to take that Docker file and build it. We will tag it. We'll call this ISSC29. That's my username. Node web app latest. I think that's all I have to do. Oh, yeah. Let's add a dot over there. Okay, so this is actually going to build my Docker container. But the next thing that I want to do is I actually want to run Anchore. So how do I do that? Well, the first thing that I'm going to do is I'm going to search the marketplace for this Anchore action that's been created. So we can see that there's Anchore container scan. And of course, we'll get some nice documentation. I like to see the full marketplace listing. But this is going to give me a ton of information of how to actually run the GitHub action, the Anchore container scan GitHub action. So this is going to give me some examples that I can get started with. Let's see, container scanning, directory scanning, as well as the action inputs and the action outputs, right? So action inputs are going to be the knobs and controls that I can do, that I can configure in order to configure the action to the way that I want to configure it. And of course, the outputs are going to be any outputs that are sent out from the action. Over here, it's going to send me the path to a JSON file of the vulnerabilities. But to me, I always like to go back to the actual repository to go a little bit, let's say a level deeper. So I'll click on links and that'll take me to the actual repo where this action was created. A number of things that you'll notice, of course, you have the README, which gives you pretty much the same information that you saw on the marketplace listing. But the other interesting thing that I always like to look at is the action.yaml file. So the action.yaml file is the source of truth as to what are the actual inputs and outputs. Sometimes the documentation can be a little slow. They'll update the action YAML, but the documentation will come a couple of days afterwards. So I always like to go to the action YAML file to actually see what's coded in. And of course, you can see those same inputs as well as those same outputs over here, image, path, debug, et cetera, et cetera. So let's move back a second and let's get started. So I'm going to copy this into my file. Okay, so oops, we got YAML always loves its exact spacing. Okay, so we're going to scan this image using Anchore. We're going to use Anchore scan action. We're going to use version 2. So version 2 is the latest version that's currently out. The way that you would, if you wanted to actually check that, we go to Anchore scan action, tags, and we can see that this is v2. So it's actually, we're going to reference this exact tag on this repository for this action. Sometimes actions will change over time. So it's usually very much recommended to specify a tag or a specific SHA because that ensures that the inputs and outputs are exactly the same. Uses, and now over here for the image, we're gonna use that image that we just created, right? So ISSC29 latest, we will use that, and that's what we will use in order to scan. So let me click on start commit. Hopefully I did everything correctly. We'll click commit file, and the CI run. So again, what's going to happen now is we're first going to build the Docker image, then we're going to run some scanning. Now, while this is running, I did want to look at a couple of other options that we're probably going to want to turn on as well. So firstly, looking at the scan action again, let's go back to the action YAML. There are a couple of interesting options. Again, these are those controls that you can start to play around with. Obviously, we used image over here, but I'm probably going to want to fail the build, right? So what fail build does is if there's a value above, let's say you have any issues, fail build will actually fail that build. That way, in the pull request, we can start to get that information. Oh, let's see, we actually. Unexpected. Let's look at that again. Oh, we have an issue. Sometimes it takes a couple of times in order to get everything configured. So let's see, we're building the Docker image. We're doing a Docker build. And then, oh, Look at that. Two latest. That didn't make any sense. Let's try that again. I see another question on latest versus specified version. So I'm going to guess that you're talking about the tag that I created. A lot of times you'll create a specific version. Over here, I was being a little bit lazy by just doing latest. But like a lot of folks will actually tag their Docker images when they build them with a specific SHA or something like that, right? So there's a lot of different ways you can version your containers. I just used latest because it's pretty easy just to get started. Yeah. All right, let's look at this action completed. It's continuing on. But as I was saying, so we are going to want to turn on fail build when this works. We're also going to want to turn on the severity cutoff. So if you could think about, like, you have a number of different options. Maybe you have vulnerabilities that are low, medium, high, critical, etc. Over here, the default is medium, but we can actually play around with that. And the interesting thing about playing around with that is it's going to control whether or not this build is going to become failed. Okay, so we can see that we've scanned the image. Scan the image. If we scroll down, so we can see that we actually found a number of different vulnerabilities. But what's interesting, of course, like as we were mentioning, we didn't actually fail the build, right? Like we got to check. So this is where we want to modify this a little bit, and then actually fail the build. So let's do that right now. Kelsey David, which repo on GitHub? So let me actually put this in the chat right now. There you go. You can follow along. Should all be visible. Okay, so let's go back to my workflows. And we'll modify a couple of things. By the way, just notice, like, it's really easy to figure out which actions that you want because it's always on the right-hand side. You can always search. If we go back to Anchore for a second. Yep, that's the one. So this will give me a couple of options. So I'm going to want to fail the build. And let's set that to true. And let's do severity cutoff. And we'll put that to medium as well. Alrighty. Let's commit those changes. So now this time around, we are expecting the build to actually fail because we specified that the build should fail if we find any at least medium level vulnerabilities. There are a couple of other things that we'll want to turn on as well. So pretty much Anchore creates this JSON file. Now, one thing that we can do is we can view, obviously, the results within the UI, but sometimes we want to actually create or store that build file, right? That JSON file with all the vulnerabilities. Well, we can do that very easily with actions, and this is where the upload artifact action comes into play. So going back, so while that's running, let's modify this again. Let's look at upload action. Whoops, upload artifact. Right, so we can upload a build artifact. That way it's visible. We can always use it afterwards. Version 2.2. We can get some more information over there. So let's do that. So name, upload artifact. Okay, we're going to use the upload artifact, and this is where we're going to specify the artifact name. So with this is where we can look at the documentation, but I'll cheat a little bit because I know that we're going to call this Anchore vulnerabilities, and the path to the file that Anchore creates is going to be vulnerabilities.json. So what this is going to do, just to review, right, Anchore is going to create this vulnerabilities.json file, and then we're going to upload the artifact. The only problem is that if we look, no, this one passed. We're going to want to look into that. Fail build. Oh, another typo. Fail build is true. Let's just commit that, run that so that we fail the build, and we'll just run this again. So while that's running, okay, so the only issue with this upload artifact now is that it's never actually going to run. So remember, if this build is going to fail, actually what's going to happen is any of the steps that occur afterwards are not going to run because the build has failed. So what we need to do is we need to put some configuration options in order to ensure that even if the last step has failed, we'll actually want to continue on anyways. And this is a great example of looking at the documentation. Looking at the documentation, oh, let's pull out the full documentation. This is where I look for this is really where I want to look at specific workflow syntax. And I would definitely recommend being very comfortable with the documentation because this is where a lot of the syntax, this is really where the syntax is, where you'll get to understand all of the different options that are available with GitHub. I'm going to look at the context and expression syntax. So this is a case where I always want to run this step. So scrolling all the way down, I can see that there are a couple of different options. Job status check function. So what I can do is I can add an if statement, and depending on the job status check, I can either always run this, I can run this, you know, when the last step has canceled, or a couple of different options over here. For this case, I always want to run this option of uploading the JSON file, even if my build has failed. So I'm going to add this if always to my step. And we'll do that over here. So if always, and we'll start that commit. Great, so now what should happen? We can see over here that this build has failed. So that build has failed correctly. Scrolling all the way down with all of the logs. Looks like there's a lot of logs. Okay, so let's just wait for this one to complete. What you will be able to see though is the actual artifact that it generates, and we'll be able to look at that artifact for you know, a lot of people will use this for archiving purposes. So this is a great way to integrate your Anchore container scans directly within GitHub itself, directly as part of your as part of any pushes that occur within GitHub Actions, or of course viewing those results within a PR as well. If you have any questions before we move on to the next topic, feel free to put it in the chat. I'll answer them right now. while that's completing, I'm just going to show you the documentation again. So looking at the workflow syntax, you can see that we use a number of different keywords, name, on, right? Like these should all be a little bit familiar to you. One of the key syntaxes that we just used was this if statement. So you can use an if, it's pretty much a conditional to prevent the job from running unless that condition is met. For us, obviously, this became very useful because we wanted one step to run pretty much always. Okay, so you can see that this job has failed. We knew that that was going to happen, but now it also has this artifact that we can download, and this will contain all of my vulnerabilities that we picked up. In this case, there are a lot of vulnerabilities that we picked up. Because this is a dummy application with, well, a lot of vulnerabilities. You can see that we are able to see that over here. So a lot of vulnerabilities. This is obviously related to the fact that I use Debian 8, so a very old version of Debian. Alrighty, moving on. We're now going to move on to the second section, which is actually really exciting for me. We're going to look at an application known as Rails Goat. And we're going to integrate Rubocop into the workflow. Okay. So the way we integrate Rubocop, and let's go to GitHub Rubocop. Let's get some more information on that. So again, like this is specifically a Ruby static code analyzer. The way Rubocop works is a little bit differently from other actions. In general, with Rubocop, we're going to install this gem. So we'll install the gem, and then Rubocop will report back what's going on. So let's do that. The difference over here, though, is we're going to use something known as code spaces. For those of you who have never heard of code spaces, I'm going to create a new code space. What code spaces is an integrated online IDE, right? So this isn't just some simple workflow editor. This is actually the full power of VS Code running in the cloud. So I can open and create a new workspace, and that will install all of the dependencies and everything that I need to do in order to get started. So this will make our lives very easy. It's right now in beta. You can check it out. GitHub code spaces. Yep. If you look for that over here, you can get some more information about how code spaces works. Of course, you can see that we're right now initializing the code space. In the background, actually, what's happening is it's building a container, the container that I specified, and this is going to give me my full IDE. Now, this may take some time in order to boot up, so I already started a code space. The reason why it's going to take some time to boot up is in the background, it's actually going to install all of the, it's going to do a bundle install. For those of you familiar with Node, it's the same thing as npm install. It's going to install all the dependencies in the background. So that usually takes a couple of minutes in order to start. I'm gonna skip that for now. So let me go back to ISSC29, go back to my repos, and we'll go back to Rails Goat. You can see, of course, this is getting started. That code space, I already have this one started up. We have a question from Kelsey David. How do I get a code space to edit code? I made the request from the beginning, but unfortunately haven't got the functionality for my account. So I do know that we are continuously adding additional users into the code spaces beta. It is going to take some time. We are prepping to GA that, so stay tuned. You should be added pretty soon. So. It'll take some time, but we're getting there. Okay, so you can see that this is my code space. Of course, like if you are familiar with VS Code, it looks very similar to VS Code. And the reason, of course, is the background. It all is VS Code. Going back to my previous code space that I created, right? So this is the new one that I created. Let's look at the creation log, just to get a little bit more information. And of course, you could see that this is where the configuration, remember how I told you that it's going to automatically create your own, it's going to automatically install dependencies. So this is actually where those dependencies are being installed. Okay, so let's do, we have full access to the terminal, of course. So let's do a bundle install. Okay, we can see that all my dependencies are already installed, but let's install a number of other dependencies. So the dependency that I'm going to want to install is, let's look at my gem file. Let's close that. And we're gonna add gem. So we're gonna add Rubocop. And I'm going to specify a specific version, Rubocop 0.92.0. Let me do another bundle install. Alrighty, we installed a couple of more dependencies. Normally I would use Rubocop, but for this, I'm going to show you something a little bit more interesting. So I'm actually going to scratch that and use code scanning Rubocop. It's a specific Rubocop version with code scanning enabled. I'll describe what that actually does as well very soon. Let me do another bundle install. Okay, installed. So now if I wanted to run, usually when I'm integrating a security tool, I'm going to run this first manually, and then I'm going to create the action workflow file just to see how it works normally. So I'm going to do a bundle, bundle exec Rubocop. So this, of course, ran Rubocop manually. We found 1,100 offenses detected. The next thing that I want to do is just understand what the output of that last command was. So you can see, of course, that over here I see an output of 1. Now, an exit code of 1, of course, means that there was an offense, right? There was a vulnerability that was detected. So this gives me, there are similar type options, of course, with Rubocop as well, in order to define what exactly is considered a bad vulnerability, right? Like we can put a severity level as well. Let's see, Rubocop. Well, I forgot where that was, but you have that option to do that as well. And then that would turn that to a 0 if it doesn't meet the specified version. So the specified critical vulnerability level. But let's actually get this as part of a GitHub action. So let me go back to github.com/issc29/railsgoat. Now that we are satisfied enough with this, oh, well, let me first commit this change, right? We're adding this new gem. So let me commit this change. I'm going to go to source code, add Rubocop. We will say yes, commit that. Let's push that to master. Alrighty, now we should have pushed a minute ago. Oh, yep, pushed 13 seconds ago. Let's get started on the GitHub Actions workflow. So again, we'll start over there. For this, So we're going to want to do a couple of things over here. We're going to want to check it out again. Yep, that makes sense. I'm going to paste over some code to help a little bit with time. So we're setting up Ruby first. Of course, we're using Ruby. We're going to want to install any dependencies. So very similar to what we were doing in the code space, we're going to want to run a bundle install. And then finally, we're going to want to run Rubocop. So we're actually going to run it in a very similar manner to how we did before. This time, we're not going to use an action, but we're going to manually run it. So Rubocop run, and we'll take that run. I'm going to want to run a command line option. So --c. Over here, we're going to want to bundle exec Rubocop. So we can do that same Rubocop, but I'm going to add in another feature that I'm going to describe right now. So let me just copy this over for time. Okay, what this is doing is it's running Rubocop, and it's also going to format our output as serif output. Now, for those of you who are familiar with serif, serif is pretty much an interchange format. So it's a format that other tools understand. Very similar to JSON, serif is the standard for security tools. And the reason why we're going to do that is we're going to run Rubocop, but now we're also going to put those results into the GitHub security dashboard, right? So you can actually visualize these results within GitHub itself. For open source repositories, this is available as natively. For private repositories or enterprise, this would be part of GitHub Advanced Security. So definitely check that out. Something wrong with indentation. Oh, unexpected end of stream. Let's get that over there. Okay, we should all be good. Let me start that commit. And commit that file. Let's look at the action that is running right now. So we have CI. All right, so remember, when we look at this workflow that we just created, the number of different steps, it's going to first check out our code, then set up Ruby, then install dependencies, then do that same bundle exec of Rubocop. But this time, we're actually going to create this serif file. The serif file, again, like we can upload this very similar to how we did it with the JSON file as an artifact. But this time I'm actually going to upload it into GitHub in order to visualize that as part of the security tab as well. And that's going to get us a lot of information directly integrated as part of the GitHub native workflow. This is sort of where we're going. So just to give you a visualization, especially for those who have open source, this is available today. You can go to code scanning alerts and start to view the results that we pick up directly over there as well. If we were to create a pull request, so let's do that in the meantime. Maybe we will change something on the README. Update the README, create a pull request. Update that README. You'll start to see that these checks start to come in as well. So you can see the CI build is currently queued. We happen to be running Travis in the background as well. But that CI build, and then you'll also get a status as well for Rubocop and anything like that. So we're getting a lot of information directly within the PR. And of course, we are now just waiting on this, on a couple of these actions to complete. Okay, so that's how I would integrate Rubocop as part of our workflow. The last thing that I wanted, or really the last integration that I wanted to go over is Codecy. Codecy is a little bit different from the last two. So we ran Anchore, we ran Codecy, we ran Anchore, and we ran Rubocop. We're not going to go over to Codecy. I already created a profile. The interesting thing about Codecy is you can run this Codecy analysis CLI action, right? So this is going to go back to the traditional way of creating an action and using a specific action within the GitHub Actions framework. But the nice thing over here as well is that there's a UI that we can start to visualize what's going on as well. So let's look at that UI first. Of course, automated code review and analysis. I'm going to look at repository. So I have this other repository, right? So this one you can check on my profile as well. Oh, well, let's find it. I'm going to go to your repositories. And yeah, the PHP Codecy demo, so you can check out my profile. This is the new repository that we're working on right now. And PHP. So let me add that into Codecy. Add repository. We're going to add that. And go to repository. Now, the first thing that I'm going to do on this end is I'm going to run the analysis through the build server. So what this does is the analysis is actually going to run on GitHub Actions instead of it running on the Codecy end. Really, all we're going to do is then pipe in the results to Codecy afterwards. That allows you to integrate this directly as part of your CI instead of having an external service have to do this. The next thing that we're going to do is we can see that GitHub is already integrated, right? So we have Codecy integrated as part of post commit hook, as well as part of, this will send back the pull request status. The thing that I also want to do is I want to add a project API. I'll show you why when we go through the action. So now we know the drill, right? When we want to add any security third-party tools, we're going to want to go to Actions and create another Actions workflow. So let's do this for the final time. Okay, we're going to check out. We're going to remove this over here. And here's where we're going to want to look at Codecy again. And we're going to check out the Codecy analysis CLI. So let's look at the full marketplace listing again. We have a couple of different options. You can see that the way to integrate it would be to use this Codecy analysis CLI engine. Of course, we can take a look at the links. This is always what I do. Go to action.yaml. Hopefully this is familiar at this point. We look at all the inputs, as well as all of the, there are no outputs. So there are a lot of different inputs that we can use with the Codecy, tool timeout, whether we want to upload the results to Codecy. In this case, we are going to want to upload the results into Codecy, and the format and stuff. A lot of this information, you can go back to the tool itself, and you'll start to get some more info on how to create this and how to do this. Before we complete the Codecy, let's just go back to Rails Goat. Oh, looks like we're still running, right? So remember, we're going back to Rails Goat right now, and with Rails Goat, just to refresh your memory, we did a couple of things looking at that workflow file. We installed the dependencies, we ran Rubocop, and we uploaded that Serif output. So what does the upload Serif output do? Now, this is where we can actually see it. So we can look at the code scanning alerts. We click on security code scanning alerts. We can see that there's Rubocop now, and that we're actually able to also visualize exactly where these issues occurred directly within GitHub itself, right? So this is ingesting Serif, external Serif output into GitHub itself, viewing this within the security tab. But now it makes it very easy for developers to figure out exactly what's going on in regards to code scanning alerts. It's important to note that this was also available for Anchore. I just decided to show it to you for Rails code, but this was definitely available for Anchore as well. You can check that out. Really, it's all about uploading the Serif file into uploading the Serif file to GitHub, and then we will analyze it and present it to you directly within the GitHub UI. In the security tab, we see a lot of information directly over here, such as the exact line that this occurred, as well as some more information as to what this actual issue is, giving some examples and whatnot. So this is a very, I don't want to undermine it. This is a very powerful feature that's part of, it's free for GitHub open source, part of GitHub Advanced Security. And this is really how we're integrating with these third-party security tools that are out there. Okay, so that's a little bit, so we've done RailsGoat, we're done with that. We're going back to our new file over here, right? We're going back to integrating with Codecy. So we checked out our code. The next thing that we're going to do, again, like I'm going to copy this over in the name of time. Over here, we're going to run the Codecy CLI. We're looking back at those options. Again, like this is, we're pretty much copying and pasting from over here. We want to be verbose, it's just the output. Over here, the output, I want it to be Serif format, right? Because we're going to want to upload that in a very similar manner to how we did so previously. And we're also going to want to upload. Now, what upload does, again, like this uploads any of the results back to Codecy. That way we can visualize this within the Codecy app. So we have visualization both in GitHub, both in Codecy, giving you a lot of different options. The last thing that you may notice with Codecy is that it requires a project token. In general, like this isn't actually required. You can run the Codecy CLI without a project token. But what this does is this allows us to upload our results back into Codecy. So we are going to want to use that. But over here, notice something. We're specifying a secret, right? So this secret is the Codecy project token secret. And it's located within our secrets vault. It's important to note that when you want to store any secrets within a, when you want to access any secrets, maybe for third-party external tools, you should never actually just put it directly into a GitHub Actions workflow, because then that's visible to everybody. So that's why we have a secrets tab over here. You can create your own secrets. I'm going to create my own, pretty much Codecy project token. Codecy project token. And of course, going back to the API, this is exactly why we wanted to create this API token over here. Don't worry, it's going to be deleted very quickly after this presentation. So we created our secret over here. Now, when we actually do run this, it's going to actually reference that secret that we specified over here. Note, by the way, like there's no way for me to ever view that secret again. The only thing that it can do is update it. So it's security for me as well. I don't ever have to remember what those secrets are. Okay, so we did that. The last thing that we need to do is upload the Serif file, very similar to how we did beforehand. Again, like this is sort of optional. Like you really don't have to do this, but this is for the visualization within GitHub as well. It makes life very easy. So we're going to upload Serif using the results.serif, and let's commit that. Alrighty, now while that's running, let's look at what's been going on the Codecy perspective. So the first time that we actually ran this, oh, we got an F. Oh, that's terrible. right? So there's obviously a lot of issues over here. Oh no, I had an issue running. Let's take some of these commits. I'm going to request a manual review over here. And so this is where the review is going to occur. If I look at a past project that I've created, you can see that this is where you're going to get a lot more information as to code style and security. So like if we want to dig into a specific code style issue, we can see a number of scripts and a number of issues, right? Like this is a good place to start to view a lot of the issues that we were seeing within GitHub itself. So again, like with Codecy, the nice thing about Codecy is that it's running a number of different tools in the background. So it's not just running a single tool, but let's see, it's running all these built-in tools like Brakeman. It's actually running Rubocop as well in the background. So beforehand, where we were running a specific tool, we were running only Rubocop. Codecy, the CLI is actually running a number of different tools from Rubocop to Brakeman to ESLint and stuff. We'll be able to visualize those things as well within GitHub as well. Yeah. Let's go. Let's go back to our PHP Codecy demo. Let's look at the action that's running. And of course, right now we're in the run Codecy CLI. So this is going to take a couple of minutes to run. But hopefully this was a good overview of how to integrate a number of these different tools. The things that I want to stress over here, one is that when you are creating, when you do want to reference new actions, definitely check out the GitHub Marketplace, either here or by Googling the GitHub Marketplace. You're going to get a lot of different actions that are available. Again, like I'm only showing you 3 specific actions today, but there are tons more available on the marketplace. One interesting other, if we look at GitHub OSAR, another interesting action, this runs very similarly to Codecy, where it's running a number of different tools in the background, such as Bandit, Binskim, and ESLint. This is, again, like there's full documentation over here, so you can check it out. And then you can also upload those results to Security tab. The one last major thing that I wanted to show you, actually, is today we edited and we created a lot of these workflows manually. But there is a very easy way to do this. And again, like if you're part of GitHub Advanced Security, or if you are using an open source project, you can create that open source project, click on code scanning alerts, and it's going to give you a number of different options based off of the language that we detect. So if you are running, like if you create a Ruby project, we'll give you a lot of different options for workflows that you can get started for very quickly. Obviously, CodeQL is one of them. But if we wanted to, for example, run Codecy, and instead of doing this manually, I can just go to code scanning alerts, click set up this workflow, and that's going to give me a full workflow file already created with all of the options already selected. That way, all I have to do is click start commit, right? So that makes life very, very easy. If we went back, for example, to Anchore, where are you? Your repositories. And go back to the Anchore demo. We can do really the same thing over here. Go to code scanning alerts. You'll notice that because this is a Docker file, because we detected this is a Docker file, we're going to give you that option to run Anchore container scanning. Click on set up this workflow. It's going to give you a very similar style a very similar style workflow to the one that we manually built. So you have those two different options of how you want to create these workflow files. Of course, these templates are all open source, so you can check them out on the GitHub organization and the Actions organization as well. And that's a very easy way to get started, to start to integrate this as part of the PR and of course as part of any push that you do to GitHub. Let's see if that PHP Codecy finished. Oh, we're still in. So this is going to take some time to go. It usually takes about 12 minutes in order to run. So we still have about another 5 minutes. Any other questions before we end this recording? Let's check the chat. So that's most of what I had to show you. You can come check back on these repos and get a lot and start to copy some of the things that I did. Of course, everything is open source, so you can check out github.com/php Codecy demo, as well as the other repos under my username. Feel free to start them. Also, feel free to ping me afterwards. Happy to answer any questions on Twitter. Twitter's also my same handle, so very easy to reach me. That's it from my end. Thank you, everybody. Also, feel free to send any questions on afterwards.